Hello and welcome to lesson 1.5. Today we're going to look at scatter plots. In the second part of this video we're going to look at scatter plots, but we're also going to look at writing equations for their lines. So our objectives are going to be to analyze data using scatter plots. We're going to write trend lines and use it to make predictions, and we're going to write an equation for what we call the line of best fit, which will also help us make predictions. So just to kind of recall, a scatter plot is something that looks like this. And ultimately, a scatter plot comes from a point in time when you have a lot of data and it's kind of hard to look at the data and see what's going on. So usually if we graph it, we can kind of look for trends or things that might be happening as a result of something else. So here, notice I still have my x-axis labeled, my y-axis is labeled, I have all my data points. They're not in a really nice straight line, but that's okay. In this case, these do kind of follow a trend line. We'll talk about that here in a second. And my graph still has a title. So based on looking at this graph alone, I can tell that we're looking at test scores and probably the amount of TV. And if I come down here and look at my x-axis, I can see that we have hours spent watching TV versus our test scores in our grades. When looking at scatter plots, we have something called correlation. Now, correlation kind of just tells us like how close are the points together, and are they kind of all doing the same thing, or are they all doing their own thing? So we have a couple different types. First, we have what we call a positive correlation. So if you notice right here, my points, although they're not in a straight line, they all tend to be kind of generally increasing as we go from left to right. We can also take note and say that as our data increases on the x-axis, it's also increasing on the y-axis. On the flip side of that, we have what we call the negative correlation. Okay, again, a negative correlation just tells me that my data tends to be decreasing as we go from left to right. It's still all kind of grouped together and it's kind of following the same general pattern. As our x values are increasing, our y values are increasing, or we could say as our y value is decreasing, the x values are increasing. So they're just kind of in opposites. And then the third scenario that we might run into is one like this, where the points are just kind of randomly placed all over your graph. There's no correlation, no rhyme or reason. It kind of looks like everything is just falling everywhere. It almost looks like it's snowing on that graph. So this right here, although it doesn't look good, okay, we can still tell some valuable information from that. Okay, and ultimately we can tell that there is no relationship between whatever is on our x and y axis. So for example 1, it says to make a scatter plot of newspaper circulation and the number of households with television. So the first thing I'm going to do is I'm going to identify that the daily newspaper circulation, which is in millions, is my x, and my y then is going to be the households with television. Again, notice that's in millions. Okay, so I just went through real quick and I labeled my x and y axis. Now, one thing I do want to point out when you're making your own graph, try to expand your x and y axis as far up as possible, because what this will do is it will make your graph look much more readable. So I'm going to take a quick second and I'm going to go and I'm going to plot my points. So when I do that, this right here, I'll have the point 54.5 or 54.4, 59.46. So actually, if I write this as a coordinate point, I'll have 54.4 and the coordinate point 59.46 and so on. So I'm going to plot these points here real quick. Now that I'm all done, this is what my scatter plot will look like. Okay, generally speaking, it looked like my data was kind of starting to increase. I do have this one point here that's kind of an outlier. I'd probably want to plot a few more points before I made any set decisions to see if there was a correlation between the number of daily newspapers and the households with TV. But for this point in time, we just had to make a scatter plot, and that's what we have right here. For example 2, We're going to make a scatter plot, and this shows a table of the number of hours that were worked and the amount of money each person earned. So take a quick second and go ahead and fill this out, and I'll graph it myself. Now, just to give you a quick insight into what I did, x-axis went on the hours went on the x-axis. The amount of money earned went on the y, because the y, or the money earned, depends on the hours that you work. Notice I did put the unit of dollars, so I didn't have to put dollars here, and my graph is going to consume most of the space that I'm given. Now I'm going to go ahead and plot my points. So once I plot my points, this is what I get for my scatter plot. Now in this case, I would say that I have a pretty strong positive correlation, because my points are all kind of grouped pretty tightly together. I don't have any major outliers like what I had before, and I tend to be increasing as I go from left to right. For example 3, it says describe what a point on the scatter plot represents. Okay, our title is called climate data, but notice we have our northern latitude for location on our x-axis, and we have our average or daily average temperature. So we could say that each point would be the daily average temperature based on the northern or the north latitude. Okay, and that's exactly what we've got plotted out here. When I look at this scatter plot, I would say that my graph overall is tending to decrease as I move from left to right. Okay, so this might be a negative correlation. For example 4, it says, what does a point represent on the graph? And again, notice we have the age and weight of 9 infants. Our x-axis is our age in months, and our weight then would be the y-axis measured in pounds. So it says, what does a point represent? Well, a point is going to represent the number of pounds the infant weighs based on age. The second part says, how can you tell if infants weighed the same? Okay, well, you can tell if infants weighed the same because my y-axis is my weight. Therefore, I'm looking for anything that appears on like a horizontal axis. So if I had a point here and a point here, these tell me that those two infants were to weigh the same. So I'm going to say they would be on the same horizontal line. And then for part C, it says, is there a correlation between age and weight? And when you look at this, as you go from left to right, it looks like as age increases, so does the weight. Now we're going to take a look at lesson 6-7, which is trend lines. So it's still scatter plots, but now we're going to write an equation to it. By definition, a trend line on a scatter plot just shows the correlation more clearly. So what it does is like an Excel program or a graphing calculator would do this like almost as perfectly as a piece of technology can get it. We are going to be doing freehand correlations and trend lines. If we get back to face-to-face, I will definitely show you how to do this on your calculators or even in Excel, but for right now we can only do these by hand. I do want you to know though, or notice, if you put this line in there, it just kind of helps you see that this set of data is decreasing, this set of data is increasing. That's why we find trend lines. Okay, so sometimes you hear the lingo line of best fit, and the line of best fit is nothing more than the trend line that shows the relationship between two sets of data most accurately. So it's kind of like it's placed right in the middle of all the points, or as much as in the middle as it can be. Okay, so a line of best fit truly does need to come from a piece of technology for it to be like more exact. And when we're using technology, we have something called the correlation coefficient. And what the correlation coefficient, which is represented by a lowercase r, well, it can be a capital R too, what this does is it tells us how closely the equation models the data. So for an R value close to 1, this implies it's a good set of data. Correlation. Okay, if you have an R value of 1, then this tells you that each point falls exactly on that line. As R gets farther and farther away from R, it tells you that the reliability of that line isn't going to be quite as strong. So we're going to take, we're not going to use a graphing calculator, we're going to do this by hand, but we are going to find the line of best fit for our data, and we are not going to find the correlation coefficient because we don't have a piece of technology to do that right now. So our year is going to be X, our dollars will be Y. Okay, so what I've done is I went and I labeled my X and I labeled my Y axis. This does say dollars and billions here, and I do apologize, but my toolbar is actually off to the side here and it keeps nicking the delete button, so that's why I had to move that up. So now I'm going to go ahead and I'm going to plot these points on my scatter plot. So now that I have my points all plotted, I'm going to go ahead and add a line of best fit. So to add my line of best fit, what I did is I just kind of drew a line that had maybe a few points above and a few points below. And then now I have to go ahead and write an equation. So what I'm going to do is I'm going to try and I'm going to find 2 points that are on or close to this point. And it looks like this coordinate point, which is at 95, 402. And let's say this point right here, which is at 98, 489. So what I'm going to do, and it doesn't have to be your actual data points, it could be if it crosses a crosshair or something like that, is I'm going to go ahead and I'm going to find the equation by first finding the slope. So I'm going to take 489, remember this is y2 minus y1 minus x2 minus x1. So I have 489 minus 402 divided by 1998 minus 1995. When I subtract and divide those out, I end up with 87 over 3, which is actually equal to 29. So now I have my slope. I'm going to select one of my points, which I'll just use this first one, and I'm going to have y minus y1, which would be 402, equals my slope of 29 times x minus, and in this case, I'm not going to want to use my x value as being 1995. I'm really going to want to use this as years since 1990. So if 1990 equals 0, this tells me that 1995 would have to equal 5 because it's 5 years after 1990. Just like the year 2000, that's going to be 10 years after the year 1990. So I'm going to come in here and I'm going to plug in a 5. And if I want to go ahead and continue, I end up with y minus 402 equals 29x minus 145. In order to simplify this, I'm going to go ahead and add 402 to both sides. And I end up with y equals 29x plus 257. So when I drew my graph, I did do the squiggle right here to show that I started a little bit later. If you notice, my graph does cross just below the 300, so that kind of matches what my y-intercept is. I did end up with a positive slope, which is a good thing because my graph does tend to increase as I go from left to right. And when if you were to go and plot this on your own, you're going to see that you probably have something similar to, but you might be a little bit off. You might have something like 29.5, you might have got something around like 31, 32, okay? As long as you're close and in the ballpark, you should be fine. And this is extremely important for you to show your work for that very reason. Please let me know if you have any questions. Otherwise, I will see you guys in class.